welcome to Coding Adventures. In this episode, we're gonna attempt to graph a function, a mathematical function, in JavaScript using the P5.js library and the CodeGuppy.com environment on a graphical canvas, HTML5 canvas. All right, so let's get started. Alright, I'm here on my desktop and I open the code editor. We're gonna write the JavaScript code to graph this function. But before that, let's take our notebook and make a little bit of a plan. How do you want to implement this program? What will be the algorithm behind this graphing of a function? Shall we? So let's look here at the notebook. And let me start by drawing a canvas. Basically a graphical canvas. And here on the platform in the CodeGuppy.com environment, the canvas has 800 by 600 resolution. It's a fixed resolution, which will make things very easy to work with. And what we want to do is basically to plot a function and eventually fill up the entire canvas. So if we are plotting the sin function or the sine function, let's say this is the horizontal axis, the graph should look something like this, right? If we are working in degrees, basically here we'll have 0. If we are working in degrees, here will be 0 to 360, right? The full period of the sine function. Of course, here will be 1, and here will be -1, and here in the middle will be 0. So, of course, on the vertical here we have 2 units and here we have 360 units. So the graph won't be up to the scale, but I think it will be much nicer to draw it this way. Otherwise it will look a little bit too skinny. All right, so we said already that we have 600 pixels on vertical, so we'll have to stretch the entire graph here. And on horizontal, of course, we have 360 points and we'll have to stretch them across 800 pixels on horizontal. All right, so this is how we want the graph to look. I'm thinking this is the best way that, or the simplest way to plot it. But let's now think a little bit about how do we intend to do it. So let's say, let me draw here a graph system, like in mathematical sense. So here we have x and here we have y. And let's take a particular function, perhaps, what function? Maybe, I don't know, some sort of a function, right? So how do we plan to graph this function? And basically when we're gonna graph it, of course, we want to we want to look like that. But you know, these functions may go from on the x-axis may go from minus infinity to infinity, which is basically not something that we can accomplish. So we'll graph the function basically on a finite interval. So let's pick here an interval. Let's say we want to graph this function on the interval perhaps 1 and 5, right? So this is our intent. And when we're gonna graph it, we'll have to specify for sure an interval on which we want to graph it, like 1 and 5. And of course, when we're gonna graph this function on our canvas, it should look something like this. So similar to here, we'll start, we'll go a little bit down, and then of course we'll go up. So we look similar to this. But how do we achieve this graphing of the function? It's basically we're gonna use a technique that is encountered also in many areas. Is we're gonna sample the function or calculate the function in various points, and then all these points we're gonna draw on the canvas and eventually connect them with a line, and that should basically resemble the graph of the function. So what we want to do is to sample the function in many of these points, as many as possible. If we sample in multiple points, perhaps will give us a better resolution. So perhaps here we can say sample in 1000 points to say, right? Maybe 1000 it's enough. And why we want a big number of points? Well, just in case our function will make here a huge peak let's say if it makes a huge peak, if we don't sample in many points, we may lose that peak because we may skip it. So it's good to sample it, or actually calculate function in many points, right? And for all these points, of course, we're gonna find what will be the value of the function. We'll evaluate the function in all these points. And once we have these points, like I represented them here, like with some dots on the graph, we can plot them on the actual canvas. So this is the canvas. So these points we're gonna calculate, first of all, when we're gonna implement the program, we're gonna calculate them. So for instance, we'll have x here, and then fn of x will calculate the function in these points. So let's take a few points here, like point 1, maybe in point 1, I don't know, here it's, let's say it's 2. Function, the evaluation of the function will be 2. Then we calculate in 1.001, and here it's a little bit less, maybe 1.99. And then we'll calculate in 1.002, and here it's a little bit less, maybe 1.98. Something like that, till we reach 5. And here, in 5, basically, okay, it's a little bit higher, so maybe the function will be 3. So this is an important step that we want to do in a code. We want to basically have a function and create this table, right? Obtain this value, evaluate the function on a range of values between the one that we specify, maybe 1 and 5, and for all this value, calculate fn of x. So this is it's a non-graphical part of the problem until now, but once we have these points, all we have to do is to represent them on a canvas by mapping them to the canvas, right? So one or well, we'll have to determine what is the minimum and maximum in here, because the maximum value we want to appear here and the minimum we want to appear here, and the same on horizontal we want to put 1 here, so, and 5 here. So in a sense we map 0, and here it's 800 pixels. We map the 1 to 5 to 0, 800, and here for the y the same. We map the maximum y here, maximum y, and here it's the minimum y that we find in this table, or minimum fn of x. We map it, the max y, we map it to 0, and the minimum y, we map it to 600. Something like that, right? And this is the second part. And once we achieve this, hopefully we should get on the screen this nice graph of the function that should look similar to how the math graph is looking. All right, so enough with the theory. Let's start a little bit coding this time. I'm gonna keep my notes handy just in case I need to refer to them while I'm doing the coding. All right, another aspect here, we said that we want to graph any function, right? If we are just graphing sine of x like we put initially, we can hard code it in the program. But how can we graph any function, right? We're gonna use a trick from JavaScript, lambda expressions. We're gonna make it nice. In other words, looking from the top to bottom, we want to implement a function, maybe call it graph function. function. This is a JavaScript keyword, and this one is the mathematical function meaning, right? So we want to map a certain function, fn, between x1 and x2. And all we have to do is now implement this one. Remember, in the case we put on the paper, x1 will be between 1 and 5, to say like that. So actually, when we're gonna call it, let's invoke it. We want to map a certain function. Let's see what function, between 1 and 5, like we put there on the paper. And as I said, for the function, we're gonna use a, a lambda expression. So maybe the function that we want to graph will be sine of x. And we can express it like a lambda expression here, right? Sine of x. Actually, it's because we are graphing sine of x, maybe we should graph it on the interval 0, 360. Like in the first graph that we draw on the paper there. Yeah, because we are working in degrees, and if we switch to radians, we should map it on 0 to 2 pi interval to get a full function in a period. All right, so with this being said, we put the skeleton of the program in place. All we have to do is now to implement the function. So let's follow the algorithm that we described on the paper. Perhaps we should have here another function, get function value, function values, that will basically receive the function, and we'll try to calculate the values between x1 and x2. And of course here inside somehow, you know, we'll receive the values in an array, let's say in that table, and we'll invoke it like this, right? So in the moment we try to plot the function, we'll go inside this function, we try to obtain the values, and after we obtain the values, of course, we'll have to invoke a function draw graph, right? That will basically receive this kind of array as an argument. Probably we'll have to pass multiple arguments to this one, but let's write this function nevertheless. Draw graph that takes an array. Oops, function. All right, so this should be the kind of skeleton of the program. I'll run it. Okay, I don't have any error. Let me rename it graph over function. And let me share this program with you on the chat. If you, the program is not yet ready, so if you load it, probably will not do anything. But if you reload it from time to time, as I'm saving it, basically you should get the program better and better. All right, so let's focus now on calculating the function values between x1 and x2, right? So with a certain step, we said that basically we want to calculate maybe to sample the function or evaluate the function in 1000 points. Actually, let's pass here in how many points we want to evaluate the function, and here we're gonna invoke it just to make it a little bit more generic, right? So we want in this to evaluate the function in this number of points. So let's have the x will go from x1, x is less or equal than x2, right? And x plus is not plus plus, actually we'll have to go with a certain step based on n. So let's calculate that step before. Step is basically x2 minus x1, we divide it by n, right? So imagine 5 minus 1, 4 divided by 1000. So that will be a very, very, very tiny step. So we loop through the x using this step. And for this, we'll just calculate the y, being evaluating the function fn that we receive as an argument in this point x. All right, so we calculated. Now all we have to do is basically to persist the value. So let's have an empty array here. It's empty array, and now let's push in an array. Let's push in the array x and y, basically a small object made of x and y, basically the x and the value in that point, so we can create that table that we said. So at this end we can return AI. It looks okay to me. Let me save it, and if we run it, still the program should not do anything, but let's go now and attempt to draw this graph, right? First of all, okay, whatever we're receiving, we're passing here. Let's just print it. Hopefully will not freeze the program because there are lots of values in this array. Let me run it. Oh, it's array, which is fine. Let me do a simple loop. Let v of AR, and we're gonna print instead v.x and v.y with yeah, maybe like this. So let's run it. Oops, I think I frozen my computer. Let's wait a little bit. Hopefully, yep, it's fine. Oh, because I evaluated the sign of x on this big interval with a very, very, very tiny step. So anyway, we can see sine of 0 is 0, sine of 0.36 is this value, and so on and so forth. And as it grows, this number is approaching 1, should approach 1, because sine is growing. Yep, it's it's in here for sine of 90 degree, which is this is close to 90 as far as we can tell, and after that, after 90 degrees, starts to go down as well, and up to the last point here. All right, so we are in good shape. We basically evaluated the functions in all these points that we mentioned. All right, let's refer to the sine function before. Let's refer to this graph better, right? Oh, but we have to do something. So we evaluated the function. Now we have to draw the graph, but we have to stretch it, right? Because normally sine function, on vertical, it goes up to 1. Here is 1, and here is -1. So it's tiny on vertical, but on the x-axis, the entire period is 360. And if we put more, it will be even more. But anyway, we have to map now the 0 to 360 to the 0 to 600, which how many pixels are here, and then map -1 to 1 to basically the vertical interval here. So what will be interesting to find out what is minimum x, but we know minimum x is x1, so we need to map x1, x2 to basically, oops, we need to map them to x1 we map it to 0, and x2 we map it to 600 on horizontal, and then here on vertical we need to map maximum y. So the maximum value that the function we calculated on this interval, we need to map it to 0, and minimum y, we need to map it to here it's 800, because there are 800 pixels, and minimum y, we need to map it to 600, right? There are 600 pixels on vertical. So in here, and 800, of course, to this one. So it's okay. We know already we know the x1 and x2, because it's the one that we're passing when we are evaluating the functions, but we don't know the maximum y and minimum y, but we can calculate them very, very easily. So let's switch to the code, and eventually, okay, and let's switch to the code. So what we can do is we invoke this function. So let's put a command here, evaluate function fn in a series of points between x1 and x2. So this one is doing, and it returns a table with values x, y. So okay, so we have this function. Now what we can do, we can and basically this is an array, right? A table slash array. We can create a function to calculate the minimum, to find the minimum y in this array, and then another function to find the maximum y in this array. And we did this exercise many, many times in the past to find the minimum element and maximum element in an array. That should be pretty easy. We can have this like this one, find min y, and we'll receive this array, and then we can have function find max y, and we receive this array. We'll receive this array and we'll return as a number, and then in the draw here, we're gonna invoke these functions. Find min y of this array, and then max y, find max y, and this array. So that's one option. But I think we can do a little bit better, because if we implement these functions, we'll have to loop on the array, on the entire array. We're already looping here, so why loop 3 times? Once when we find the values, one to find min y, one to find max y. I think we can do better, so we're gonna remove these ones. And actually, as we calculate the function, let's calculate also what will be the minimum and the maximum y, all right? So let's have inside here, let's assume first of all that minimum, yeah, we calculate just minimum y and maximum y, so we'll just name in mine, not And let's assume, you know, we'll implement that algorithm that we implemented so many times, but let's assume this one is basically infinity. So basically a very, very big number. This is a construct in JavaScript. And once we find the first value smaller than this one, immediately we assign that one. So let's start with assuming that with some a little bit wrong assumption, but very safe. And this one is minus infinity. And now as we are calculating the function and we are pushing here, let's compare also if this value that we just found, if y is less than the minimum, right? Immediately minimum becomes this new value. And we can also compare if this y value is greater than maximum, maximum becomes this y value immediately, right? So in this way, with a single for loop, we evaluated the function, we calculated the minimum, we calculated the maximum. It's a small optimization that never hurt. So what's next? Oh, we have to return these values. So in order to return these values, we have to return a more complex object, not only this array, basically, right? So let's return an object made up of, say, values, and we return AR as value, and then min and max as the other two properties of the array, right? So when we're gonna invoke now the function, we return an object with three properties: the actual values, the one that we calculated and we saw that they are correct, and then the minimum and maximum. So here basically this one will receive these values. So let's see, we are inside the function. We are inside this function here. We calculate, we invoke to get the values. Maybe we should extract them here. Yeah, maybe we should extract them, and we make the graph function receive these values discretely, right? So at this point we have this one. This is an object, right? From the function we are receiving this object. So the values will be o.values, the minimum, or let's call this one y1, right? It's the o.min, and y2 is o.max. I name it y1 and y2 similar to how we have here x1 and x2, right? And now we can invoke the draw function. We can pass the values. We can say we want to draw the graph of the function on x1 and x2. And also we can pass to this function now, we can also pass to this function the y1 and y2. So this function will have everything that it needs basically to draw the graph, right? So let's go in this one. And okay, we'll receive an array of values. We can leave it here AR, or there can be values. Yeah, values is fine. And here we receive x1, x2, y1, y2. Let's see the prototype again. It matches the invocation. It matches the invocation. All right, so we are in good shape here. We don't need, of course, these lines, and we don't need to draw it. So let's see how we're gonna implement this particular function. Obviously, we need to loop through all the values, and each value map it to actually the canvas pixel there and draw it somehow. So let's implement a loop, and we're gonna use a for I instead of for of, because we have to access the current value and the next value, and you'll see in a while why, because we want to connect them with a line. And we'll start with I0, I less than values dot length. Let's go one less, because we want to access also the next one after that, so we don't want to risk into going into problems, right? So we are looping through this one. So what will be the x at this point? X will be values of I dot x, and y will be values of I dot y. because this one it's is basically this yeah, x we have in each object and x and y, so we should be good. All right, so we accessed the x and y. Now we said we need to map this one to the actual canvas, because otherwise if we draw if we don't map them, the graph will be either very tiny in the middle of the canvas, or will be very big. So if it's very big, we need to compress it to fit the canvas. If it's very tiny, we need to expand it and fill all that canvas area. So the way we're gonna map it, we're gonna use the map function. And map function is a function from P5.js library, so we use it several times in the past. Let's remember how to use it. So let's say we have a screen x value, right? And screen x, we are mapping x that goes between x1 and x2, and we are mapping between 0 and the last value on the horizontal, which is 799, or we can say width -1. Width is a constant that gives us the width of the canvas. So width -1 is 0 to 7, so it's 799. Because 800, there are 800 pixels, but we don't want to go outside one. All right, so looks fine. And then screen y, we map y that goes between y1 and y2. And now we know these values. They are the minimum y and maximum y. And we want to map it between 0 and height -1. Actually, we'll not map it like that. We'll map them in reverse. And the reason we are mapping in reverse is because, let's look here again. In math, the y goes up, right? And x goes to the right. Here on our canvas, x still goes to the right, but y goes down. So because of this thing, we want, when the y is maximum, we want to map it on the canvas to 0 value. And when y is minimum here, we want to map it to the 600, like we put here actually, right? So we map it in reverse in order to not have the graph flipped. So yeah, that should be fine. And now we have a point that we calculated with the function. We have it mapped to the screen. Let's do the same for the next point that we have here, right? The like we did for the x and y. Let's say for the next x and next y. So which will be basically we'll have to duplicate this code a little bit here. But so basically next x we said, or x next, x next, and y next. The next value after x. And that one should be I + 1. And now you see why when we iterated, we stopped with 1 before, because we are accessing here +1. So we don't want to go over that range. And the reason that I want also to access the next one is because I want to connect with a line. This point, the current point, with the next point. So we'll have many tiny lines connected. Let me show you on the paper here, just to better understand what I'm planning to accomplish here. So this is on the canvas, right? We are mapping, let's say, this function above, and we have all these nice points drawn here. If we just use the point instruction to plot them, they look like that, which they may look a little bit discrete. They are not what we want to achieve, but if I'll calculate this one, let's say this is the x and y, and this one is the x next and y next. At any point when we are looping, we can just connect with small segments of line the current point with the next one. So basically we should have a kind of a continuous graph. Hopefully. So let's see if the graph turns out correctly. But that's what we are doing here. And let's map also x next and y next to the screen as well. So I'm gonna duplicate these lines and let me adjust them. So screen x next, I'm just using this suffix here, and we are mapping x next and y next. And the rest should remain the same basically, right? Because they go between the same thing. And we are done. Now it's time to connect this point. So we'll have a line, like we said, between screen X and screen Y and screen X next and screen Y next. All right, let me save you. So if you are watching this live, you can reload the program and let me run it, see if I get anything on the screen. Wow, this is impressive. It worked from the first time. That's kind of interesting, but it's a good accomplishment. So we have the sign of the graph of the sine function plotted on the interval 0, 360, which is looking exactly like we want, right? And since this CodeGuppy.com is based on P5.js, we can use P5.js functions. So let's switch to radians. If we switch to radians, we can plot it on 2π interval here. We should get the same thing, right? Should get the same thing. Let me save it. What about if we plot it on 5 pi's? Yep, works correctly. Let's animate this one. I'm thinking of creating a rolling window. Like on horizontal, X and Y are not between 0 and 5 pi, but they start at certain position, probably 0, but then it goes either to the left or right. So let's have a variable here, start, that is 0, and then we're gonna implement the function loop. The function loop is a special function. We don't have to invoke it ourselves. The browser is invoking for us 60 times per second, so we can achieve animations this way. We clear the canvas and we're gonna move the graph of the function inside here. And if we are doing just like this, should not be any different, all right? But we want to plot it from start to start plus 5 pi. So we keep the interval, but now we increase start or decrease. We'll see. It's going too fast. 0.1. All right. So this is the animated graph of the sine function. All right. All right with playing. Let's test it for other functions. But if you like this one, save it. Make a copy of it. For now, I'm gonna just remove the animation because I want to make sure that implementation works fine and it's solid for any other function. So graph of the function. We can keep angle mode radians if we want, or we can just default it to degrees. Yeah, we can default it to degrees. So this function we saw is working. 360, it's fine. 360 degrees times 2, we should have 2 periods. All right, we have 2 periods. What is a little bit difficult to see right now is to actually get a glimpse of the values. So what is good is to implement perhaps to display also the axis, right? That should give us a little bit of a more a better understanding of what we are seeing here. So in the same graph functions, let's also say draw axis. So we're gonna create a function, draw axis. And of course, axes are just 2 simple lines. The question is, axes, they go through 0 and 0, right? So, and depending on the interval, for instance, here, yeah, let's make the draw axis receive x1, x2, y1, y2 as values. X1, x2, y1, and y2. So the horizontal, so basically there will be an axis between x1 and x2 and another axis between y1 and y2. Of course, if x1 should be less than 0 and x2 greater than 0, will be between them. If they are not, and the same for y1 and y2. So we can use the same map function to find, for instance, the axis x, and we can map the constant 0 that goes between x1 and x2, and we'll map it that goes between 0 and width -1. Something like that. And axis y, we're gonna map again the constant 0 that goes from y1 to y2, and we're gonna invert them, just like we did before, because we want to make sure the graph is in the correct orientation. So after we calculated the axis x, all we have to do, we have to draw a line. So the x-axis, right? It's axis x that will go from and 0, like on horizontal and 0, and then axis x and height -1. Right? So we go on horizontal with axis x that we calculated here. All right, and then we can do the same for this one. We have a line 0 and axis y, and then 0 and vertical axis y. Actually, they are and here width -1, and basically here we have axis y again. So 0 and axis y. Actually, this is I put axis x and y, but they so we have them. We have a line here and a line here, but I think this one, the second the second one is actually the x-axis, not the y-axis. So let me inverse them, and this one is y. Just as a meaning, just to be, you know, a little bit more correct. So this is x and x. Now should be the same, but anyway, we have the meaning of the variable should be better, because right, the axis x is between the y. And now we can make an optimization here. Even we can say if x1, if 0 is between x1 and x2, only then draw this one, and the same we can do these ones. Otherwise, the line may draw things off canvas, but it's fine. It doesn't matter. So let's draw this one with a different color. So perhaps this one is stroke black, and this one is stroke weight 1. Let's make them axis black, and eventually the graph will make it blue or something like that. Draw graph function. Where is that one? Indeed, the other one. All right, here. All right. Let me move this around just to have it in front of calculating the values, and eventually in front of drawing the axis. Or after the axis. All right. Here, and this for this one, let's have a stroke blue and stroke weight or navy, some sort of a interesting color, and perhaps a little bit thicker. All right, so if we run it, yep, we still have the graph. Now we don't see too well the y-axis, but if we are representing from -180 to 180, we should still have the same interval, but the axes are in the middle, which looks a little bit nicer, right? So let's play with a different function. Perhaps we can comment this out, and let's play with a different function. Perhaps a polynomial function, such as x squared plus 2x minus 3, right? Oh, but this is a polynomial. We don't have to represent it on such a big interval. Perhaps we represent it on -5, 5. Let's draw this one. It looks like a parabola to me. I'm not sure if it's correct though. Let's go to this Wolfram Alpha website. Wolfram Alpha. Yep, this one. Hopefully it will load. Yeah, it's loading. And let's try to plot the same function here. X squared plus 2x minus 3. Enter. Come on. Enter. Okay. All right. It looks correctly like a parabola. Let's represent it on the same interval that it says here. See if it looks the same. X from minus 3.4 to 1.4. X from minus 3.4 to 1.4. 1.4. We'll run it. And indeed is looking like the all from alpha. If I'm looking correctly here. So it's kind of the same, right? Here we have minus 3, here we have 1, and it goes down exactly like it should be. Let's represent it also on minus 13 and 11 in our code. Minus 13, oops, minus 13 and 11. And if we'll run it, yep, looks exactly like this one. So I think we have a success. What we are missing here is to basically draw this kind of a few tick marks eventually on the axis, or eventually even put some points like we have here in all from alpha. That will give us a better indication of what's happening here. But even without that one, I think what we plan to achieve, we achieved it. So let me save it this one again. Let's make this one blue, and let's put a nice background yellow, and let's run it again just to be a little more colored. I hope you liked today's exercise. If you like it, and if you build upon this code, that you can find it in the comments, please put your version also on the comments or send me a message. And again, thank you for watching. Have a nice weekend, happy coding, and see you next time.